Okay, so moving on to paragraph section. First paragraph is based on question number 51, 52 and 53. It says that consider the following functions. Fx is root under log to the base half mod of log to the base 3 of mod x. Gx is x square minus 3x plus k whole divided by x minus 1. Capital Fx is 4 sine of x by 4 cos of x by 2 cos of x by 4 whole divided by x. Now give the answer of the following questions. Question number 51 says that which among the following intervals are the subsets of domain of fx? So students, when we talk about domain of this particular function, so we will have to apply the condition pertaining to under root of a quantity, that is under root of this complete number. So this complete number has to be non-negative. So log to the base half mod of log to the base 3 mod x has to be greater than or equal to 0. So let us solve the inequality. We have mod of log to the base 3 mod x less than equal to 1 by 2 raised to power 0. So that is less than equal to 1. Removing the mod, we have log mod x to the base 3 belonging in the interval minus 1 to 1. And this will give us mod x belongs to the interval 3 raised to power minus 1, 1 by 3, 3 raised to power 1, 3. So this is the condition of under root expression. Okay. Second condition. The number of a log must be positive. So let us consider the number of log to the base half. That means mod of log of mod x to the base 3 greater than 0. Students, mod of any particular quantity is always non-negative. This inequality says that it has to be positive. So that means log of mod x to the base 3 is not equal to 0. That is the only condition which will be rejected under the given circumstances. So we have mod x not equal to 1. Fine. From the second condition. Now let us have the third condition also. The third condition is pertaining to the log of base 3. We have mod x strictly greater than 0. That means again x is not equal to 0. So final domain of fx is the intersection of this condition and this condition. So we have minus 3 to minus 1 by 3 union 1 by 3 to 3 minus only two elements pertaining to mod x not equal to 1 minus 1 and 1. Okay. So we have this as the final answer of the domain of small fx. Now we have to decide which of the following intervals are the subsets of domain. Definitely option A is correct. Option B is wrong because 1 is not there in domain. Option C definitely correct. Option D is 4 to 5, definitely wrong. So final answer of this question is option A and option C. Okay, let us move on to 52. 52, it says that if limit x tends to 1, g of x is equal to L, where L is a non-zero finite number, then students, we can see that the denominator of gx tends to 0 as x tends to 1. So the numerator also will have to tend to 0. That means x square minus 3x plus k at limit x tends to 1 should be 0. Only then 0 by 0 format will be created and we will have a non-zero finite number as the answer. So from here you'll get k is equal to 2. So if k is equal to 2, what is L? L is limit x tends to 1 g of x, and that is x square minus 3x plus 2 upon x minus 1, and which is limit x tends to 1 x minus 2. So this is equal to minus 1. So k is equal to 2, L is equal to minus 1. We have 2L plus k equals 0, correct. 2L plus k equals 1, wrong. L plus 3k equals 5, yes, correct. 4L plus 3k minus 4 plus 6 is equal to 2, correct. ACD is the final answer. This one is a very simple question. Let us move on to the next one. 53. If box x represents greatest integer function and the curly bracket represent fractional part function, then we have to find out the right hand limit of box of f of fractional x and the left hand limit of box of capital F of fractional x. So students, we have capital Fx as sin x by 4 into cos x by 4 is sin x by 2 divided by 2. So this will be 2 sin x by 2 cos x by 2 divided by x, and that is ultimately equal to sin x. upon x. So f of fractional part x will be sine of fractional part x upon fractional part x. So if I talk about RHL, that is limit x tends to 0 positive, f of fractional part of x, this will be 1 negative, slightly less than 1, because it will be sine h by h and it is slightly less than 1. So if I am going to take greatest integer of this value, this will be 0. Okay. So RHL of the greatest integer of f of fractional x is 0. That means A is correct, B is wrong. Talking about LHL, limit x tends to 0 negative, sine of minus h. The fractional part of minus h tends to minus 1. So it is sine of minus 1 upon minus 1, which will be sine 1. Sine 1 upon 1. So f of fractional part x is equal to sine 1. Sine 1 is obviously a value which is lying between 0 to 1. So if you take the greatest integer again, the answer is going to be 0. So very carefully, we have option number A and option number C as the correct choices of this problem. Let us move on to next one, that is 54. Let us move on to the next paragraph. Students, in this particular paragraph, based on number 54 and 55, we have in the defined conditions, the coordinates of variable point P are sine theta plus cosecant theta by 2, sine theta minus cosecant theta by 2, where theta is a parameter. The locus of point P is curve C and N is a normal of C. N intersects x-axis and y-axis at A and B respectively. And the locus of midpoint of AB is the curve S. Now, answer the following questions. A lot of information, let us process it slowly. Okay. So we have P as, let us say h comma k. So 2h is sine theta plus cosecant theta. 2k is sine theta minus cosecant theta. So from here we have 4h square equal to sine square theta plus 1 by sine square theta plus 2, and from here we have 4k square equal to sine square theta plus 1 by sine square theta minus 2. So we have 4h square minus 4k square equal to 4, or h square minus k square equal to 1 as the curve which is given as C. So this curve is C. Now, after this, the story says that N is a normal of C. So N is x cos theta plus y cot theta is equal to 2. N intersects x-axis at A. So A point is 2 secant theta comma 0. Y-axis at B. B is 0 comma 2 tan theta. Further, locus of midpoint of AB. So let midpoint be M. M is secant theta comma tan theta. The locus of this particular point is S. No doubt, students. S is again x square minus y square equals 1. So S and C are same curves. Distance between the common tangents of S and x square plus y square equals to 1 is less than. So let us draw the diagram. This is the circle x square plus y square equals to 1 given in the question. The obtained curve, that is the curve S, is a rectangular hyperbola x square minus y square equals 1. So this is the rectangular hyperbola. So we have very simple common tangents to these two curves. The common tangents are the lines x equals 1 and x equals minus 1. These are the common tangents. Very simple. 1 and minus 1. So what is the distance between two common tangents? It is simply 2. So 2 is less than 3, 4, 5. BCD will be the correct answer. Okay. Let us move on to next part, that is 55. Again, we have to tell which of the following options are not true about the curve S. So S is the rectangular hyperbola, x square minus y square equals 1. Angles between asymptotes definitely 90 degree, so it is true. That means it is not my answer. Eccentricity is root 2. That means B is wrong, so it will be my answer. C part, equation of tangent of S at 2 comma root 3 is 2x minus y root 3 equals 1. Equation of tangent is t equals 0, x1 minus y1 minus 1 equals 0. So definitely C is correct. Therefore, it will not be my answer. S intersects y at 2 points. We know that S can never intersect y-axis because as soon as we put x equals 0, we get no particular solution as the equation is y square plus 1 equals 0. So we have D option as wrong, so it will be my answer. BD rests as the final answer of this question. Okay, let us move on to match the column type problems.